Hello, welcome to another Random Code stream. I am going to be working on this issue, specifically working on adding a project. That's the word I was thinking of, a project to measure performance between the implementation I did and another one, and then see if there's any differences between the two. So let me get my music started. So that is in the background. All right, so I did this yesterday. You can see the tests here. So if you get a big integer that looks like that, and we say we want to format it with a decimal format, or I should say a digit format, with 4 leading and 4 trailing numbers, it would actually end up doing a ToString would do this. Okay, so that's great. And that all works. But I'm kind of wondering, the way that we did it is, it's really, this is all just preconditional checks. Is we get a positive version of the number, we, excuse me, we determine the base of the number, then we get the number of digits using this formula, and then we get the left and the right side if we want digits. And then we also put a dash in front to make it negative if we need it. And this all works fine. So the actual implementation isn't too bad. But what I was thinking is, well, is it actually quicker to do a ToString on a number with the right format and then just trim, get the substring or the contents of that string where we want it to be, and then just return an interpolated string with those values? Maybe that's actually quicker for smaller big integer numbers. And maybe there's a cutoff point where this becomes the faster way to do it. And so to get the number of digits isn't that big of a deal. You just say, you get the log, which gives you double, and then you get the number of digits. And then we could use that and say, hey, if it's this amount, if it's under this amount, then maybe we do it that way. Otherwise, we do it this way. Who knows? Who knows? So we're gonna throw in another method here that's just gonna be the one that takes a format. Okay, and we're just gonna call it ToString2 because we don't know if this is gonna stick around or not. Okay. And what is this complaining about that doesn't have, code path? Okay. And we're going to assume all of the things are correct here for now. Okay. So what we want to do is we want to say var value is equal to self.toString. Okay. Passing in I think we had to do the format, right? Yeah, so we can do format here. Okay, and so now we also got to be careful here because it will put a negative sign in front of the number if it's negative. So we got to be a little careful with that. I think it will do that for a hex format as well. So what we want to do here is we want to say return okay, and what we want to get here is var left part, which is equal to left digit count being greater than 0. If that's true, then we do something, otherwise we do something. And we're going to do the same for the right part. Okay, and so then here we're going to put in left part and right part. Okay. Now the right part is arguably a little easier, which is if we want digits here, what we want to do is we just want to grab those end digits at the end. So we're going to say value.substring starting at the length of the string minus the right digit count. So is that true? Let's just say, for example, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And we wanted to get the last 3 digits. And the length of the digit is 9. So this is 0, 1, 2, 3, 4, 5, 6. So we want to start at 6. Right? Because this is 0, 1, 2, 3, 6. That's where we want to start. So it would be the length of the string 9 minus 3, and that gets us 6. And this is probably going to say use the range operator. Okay. Now the left part's a little bit trickier because we have to consider if it's negative. So if self is less than big integer 0, that's going to lead to a case. Otherwise this. Okay. This is one of those things that I actually don't mind terseness with ternaries. They can get a little too terse, but you know, it is what it is. So if it's not negative, then it's easy. We can just say it's the value substring where we start at 0 and we go left digit count. Okay. This one's a little tougher. I think we want to say here, it's not a lot tougher, it's substring. Start at 0, but we go left digit count plus 1. And this should do what I think it does. Yeah. And that's it. And so, in some ways, I mean, it's slightly easier, it's slightly not, but it is what it is. Okay. So, now what do we want to do? Well, let's just do some tests on it real quick. We're going to say 2. 2. Okay. And now let's see if all these test cases pass. Well, 8 fail. Oh yeah, so if it's 0, okay, that's fine. That was just a miss on my part. We gotta do this. Okay, so if left digit count is that. Now if it is this, then what we do is a minus, else that. There we go. That should take care of it. Nope, did not. Huh. It's like it's getting all of the... There's 6 of them. There's 8 cases with a hex, and 6 of them are coming out incorrect. They're all the ones that are negative, right? That's interesting. So they're all the negative cases of a hexadecimal. So let's actually see what we're getting here. Yeah, so it is a negative number. But we get this. If I do... let's say new big integer. Or just something simple, minus 4567. And I say ToString passing in x. Now if I do calc, and let's get into programmer mode, and I type in hex and I do EE29, it's not even close. It's totally different. So we're gonna have to do the absolute value of it and then add the minus in front to do what we want to do correctly. And again, I get why this is different, because what's happening is this is this thing where you want to round trip the ToString value to say, hey, if I have a negative hexadecimal value, then to a big integer in C# world or .NET world, if I say, sorry if this is a little small to see in the immediate window, big integer dot parse EE29, the value cannot be parsed. Is there like a format that you have to pass in? Hex number. And see, it gives back a negative 4567. Which is correct. But I find this to be so weird. Like if I wanted to take 4567 here, okay, and let's go ahead and say minus 4567. This gives us a hexadecimal. Oh, I'm sorry. I did not put a minus 4. Why are you not minusing the value? Let's just say 0 minus 4567. There we go. And now you see the hex here is, it's like it's all these F's in front of it. And so in this world, this is how you format a hex number. That's negative. So if I did this and I cleared everything out and I go into hex and I put that in, it gives the decimal back. I get it. It's how you store the number and how it gets represented out. So maybe what I need to change in both implementations is not putting a negative sign in front, but letting the number actually be yeah, this starts to throw a wrench into a lot of stuff that I was assuming before. Because we can't do the absolute value of it. And we don't want to put a minus sign in front of the hex because that's not what .NET does. But in this case, we're not trying to round trip it either. Like, you would never round trip this value because you can't. You can't pass it into BigInteger parse. We could provide a static extension method for parse for this format to say it's like a truncated parse truncated or something to round trip it. But we can't. It doesn't matter because we're purposely removing a bunch of data within for you to not have to see, because you don't want to visually see that whole number. And so arguably, is it correct to even have this call ToString? It's semantics. It's really semantics. But it is true that we may not want to put the minus sign in front, and we may want to use the numbers that are coming through. We have to do this because we need to get the number of digits that are in that number. And I would assume it's the same if you do a hex either way. I had to put my pinky up there because my coffee's getting down to the bottom, and then when this heater gets the top or gets the bottom pretty warm, because it doesn't have as much liquid to disperse the heat into. So, well, if anything, I'm glad I did this, because this is really starting to make me think. What is the right thing to do? Because we can't do a log. I've already tried this. You can't do a log on a negative number. You're going to get an error. Like if I go into .NET Lab, it's just easier to do it this way. No, why did you do that? And I say BigInteger.parse minus some number. Okay, and then I say BigInteger.log of that, and I say run. You get not a number. Oh, not the parse there. So that's giving you basically how many digits are in there. But if we say console.write line BigInteger.parse, that gives us that. If we say that, that gives us that. But now let's say to string x. And then let's do the same thing here. In this one case, we are getting we're getting 5 digits. But here's the thing too, when we use this format, and that's the hard thing about this, is that we don't know if it's positive or... Simply looking at this, I would have no idea that it's a negative number. You know. Now, conversely, one could say, well, if you want to know if it's a negative number by visually looking at the number, format it as a decimal. Or, I'm sorry, as a digit. And that would be true, because the format puts the negative sign in front. In a hexadecimal format, it doesn't. So would it make more sense if, like, I wanted to get the first and last digits of this, I can't edit this, is to, like, just do f ... 7, or get the positive version of it, do negative 0 ... 9. I'm almost starting to think that having a hexadecimal format for this doesn't make any sense, because there's no meaningful way to see, did you mean positive or negative? You're going to lose too much, even if you're smart enough to look at this and you know the ins and outs of BigInteger, and you go, ah, yes, I know that is going to be a negative minus 43,145, or it's at least going to be a negative number. I couldn't look at this and tell you that, but I can tell you that this is definitely a negative number. And so I'm really starting to think that maybe just getting rid of the whole format thing and saying this will only format in decimal if you do it this way. Doing it in hex or octal does not make any sense. Yeah, I'm kind of agree. So I'm glad I did this. I'm glad I did this experiment, if only just to do it, because it's made me rethink all this. That does make the implementation a little bit simpler too. We don't have to worry about the base. We don't have to worry about formats. We can just say it's decimal. So let's do that. I think that's the right thing to do, now that I've played with this enough. So this is not going to be that. We're going to get rid of this. There's going to be no sense of format here. The base is now just going to be 10. All right. So this is just going to assume a D. And then we can just put 10 in here and get rid of that. Actually, no, let's keep that in there so that we can be clear about the base that we are in. And then there is no sense of format here. Okay, so now if we go to our tests, we just say format. or ToString. Because none of this matters. Okay, and then we uncomment these and we get rid of this. This no longer, yeah, we can actually just, we can grab these because now we just get rid of format here and format here, and we're done. And we no longer have any, this is ToString 2. Yeah, we don't have to care about any of this anymore. This doesn't matter. This does. Except we want to, I don't know what I was calling them. It should be ToString. And then that. And then this is ToString. And then we get rid of that. That is much better. There. Okay, so now at least we got parity. We don't have to worry about any of this hexadecimal nonsense. I thought maybe that would be interesting for somebody to do, but it's going to be way too confusing as to what you're actually producing. So let's just keep it as we're showing you the decimal output, and here are your numbers. Okay. We still need to do the flip here because to do like the POW and the divide and the rem, we do need to have a positive value here. There's just no way around it. So we have to do that. It'd be oh, there's a sign thing here. Okay. If it's -1, there. Because if it's a 0, it doesn't have it. Okay. And it would be really nice if there was like a log. There's a log 10. Which is exactly what we want. Right? And then there's none of this. This really isn't a base, I guess. Yeah, then they all work and they're fine. And then actually, we don't need this trim. We can get rid of this. Because that was only there . Yeah. There. That makes it even a little bit more simpler. Okay, cool. All right, so good to know that we're doing this correctly. Now we want to do the which ones. which one is correct. Which one is... They're both correct in terms of how I'm defining correctness. But which one is going to be faster? So this is where now I want to add in a console app. Spackle.performance. Okay. And then here we want to add in benchmark dot install. Yes. Okay, and then we also want to reference the project. There we go. Okay, so now we want to have a class in our BigInteger ToString. Okay, and so this is going to be our memory diagnoser. And so we're going to want to have... Oh, I know. Oh, wait, hold on. Let's not bring up this project. I know which project I want to bring up. Let's go to busting.net. This is a talk that I do on busting.net myths. And so, Sachkin Kumar, hope I said that right. Hi, how you doing? This one has exactly a test that I'm looking, well, mostly a test I'm looking for. So, I hate that keystroke. It's Control W, I think. It should be banned from the world. Shut up. Benchmark will yell at me if I do that. What I want to do is like a parameterization of different numbers. So how do you do that? Parameterization. So if we want a param source, right? No, we don't want arguments. Because we don't want the... In case you want to use a lot of values, you should use argument source. See, and this is where I... Sorry, I'm looking through this and trying to get my... So if you want to pass in an array as an argument, we're going to allocate before running the benchmark, and the benchmark will not include this operation. Yeah, that's what we want. We want to pass in a big integer of a certain size. So I just don't like that this is not type safe. But it is what it is. So we want to have a public enumerable of object array because reasons. We'll call it data. Wait. So we're going to yield return a new object that, whoops, has a big integer dot parse of, let's say, there's so many variables here, but let's try to keep it simple. Let's say we're going to want to grab the first two and the last two digits. So we're going to need numbers that are at least 4 long. Okay, so we're going to put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay. So that's 10. Now let's do 1, 2, 3, 4, 5. So that's 10. Let's just do 10, 20, 50, 100, like that. 10, 20. And let's throw in the negative versions of them as well. So it's 1, 2, 3, 4, 5. 2, 3, 4, 5. So that's 50. Now we want 100. That's 100. And then let's do 500. And let's just see what we get with that. So this is 100. 2, 3, 4, 5. 2, 3, 4, 5. Okay. So let's just say length equals 10. This is 20. 50, 100, and 500. Okay, so now what we want is a benchmark baseline equals true, public string call ToString. Except what we want to do is get the argument source name of data, Laughing Buddha, hello. Ignore that. Ignore that. And so now what we want to do here is what we want to say is, since it's length 10, let's do 3, 3. So that would be a little bit easier. We want to say value.toString passing in 3, 3. There. And that's all we're going to do. And then here, we're going to say call ToString 2, 2. And it's not the baseline. Okay. And then all we need in the program is the runner, that's right. Except we want big integer ToString. I get this question a lot. It's simple. You just got to find learning sites, Code Academy, Brilliant.org. There's code. There's so many sites to just start learning how to program. Just to try to find these learning sites and dive in. That's the same way I did it. Even years ago, I bought books and learned. All right, so we have that. We need this to now be the startup project, and we are in release mode. Let's see what we get. Yes, practice makes perfect, or practice makes better. There are techniques you can use and practices to, I guess, learn stuff better. There are experts on that I'm not. But nothing replaces effort. You got to put effort into it. It's just as simple as that. Just watching numbers scroll by. But hopefully this gives us an indication as to what's better or worse. And then if we start seeing any change, we could just change the test to like doing a length of 1,000 and then 5,000 and see what happens. But this is what I tell people in talks that I do. If there's ever a question about, well, which is faster or this is better, and I'm just like, well, how do you know? Measure. And that's what benchmark.net is so good at doing. And it's so simple to set up these tests and to let it figure, to let it gather metrics the right way. Not doing stopwatches, not doing GC pauses or collects or anything like. I mean, it might do that underneath the scenes, but it is a extremely robust, well-tested, well-designed framework. Use it. It's just simpler to do that. It does take more time because it has to, statistically weed out all the noise per se, but it is the right way to do things. If somebody comes to me and says, well, we need to do this because it's faster, and I'm like, well, how do you know it's faster? Well, because it's going to, here in the code, it's not going to do this allocation, and here it's going to do, and it's like, do you have numbers to back that up? No, we'll do that. And you might be right. Your intuition might be right, but it's, you have to have a scientific approach to it. You have to try to be as objective as you can. Intuition is good, but intuition doesn't get a rocket into space. You know what I mean? You have to go through all the analysis. You have to go through all the testing to make sure that things are as correct as you think they should be. So. You're welcome, Buddha. Again, I get this a lot. I get this a lot during my streams when I'm doing coding streams. How do I get good at coding? How do I start? It's like you just have to. There's no simple. It's not that it's hard. I mean, it can be hard depending on things, but it's like anything in life. How do I learn how to do this? Learn, study, practice, try. I mean, that's the only way you're gonna. How do I learn how to be a doctor? Well, I'll start reading medical books or literature. Take courses that are related to medicine and surgery and all that other stuff. Get an internship in it. I mean, It's the same no matter what other field. There's no difference. Thank you. Appreciate it. Appreciate the sub. Just give me a number already. Let me see the data. This is also 6 of 20. That's right. I forgot that if you see the tab on the upper left in the console window, you'll see that's telling me that there's it gives now an estimation. It tells you how many things it still has left to do out of like now 5 of 20. And it thinks it should take 1 more minute to finish. So that's nice. So it's like it's doing that kind of estimation as it's running the tests to go, well, we have these many tests to run. And like the first one took this long, so that we give you an estimate to say we think it's going to take this much longer. And then, of course, if that changes, it will change that estimate. But that is, it's just a nice, you know, lick your finger and put it in the air to get kind of a feeling for where the wind's coming from. So. Exams tomorrow, so we'll be back tomorrow. All right, well, I don't know if I'll be here tomorrow. I don't stream every day, but Random.Code streams, coding streams, they literally are random whenever I feel like it. I do gaming streams as well, but you're probably not interested in that. Maybe you are, I don't know, but I should have more of a schedule for these, but the coding streams are just kind of like, oh, I have an idea, or oh, I want to build this in my library, and then I just will stream when I want to. So, all right, finally, data. So let's just grab all this, and then we can look in like VS Code what it looks like. Okay, so it's a little hard to see here because it did like the 5 and the 10. There should be... Did we... Yeah, we have an 11 here. There should be an 11. Why isn't there an 11? And by the way, this is benchmark.net's. It doesn't use mine to find it. It's using its own way of formatting it. So it's kind of trying to do the same thing. Shouldn't there be... Oh yeah, this is 10, this is 20, this is 21. Give me a second because I want to reorder this so that it's kind of like going in order. It's really not doing that right now, which is fine. So we're going to grab that, and then we're going to put that here. And then we want to put 50 and 51. And then we want to have 100 and 101. Because this way it'll be easier to see trends, I think. And then 500 and 501. There. And then we're going to want to just throw in a blank here. And then we can pull this out here. Okay, so that's... And then we want to just put the... Wait, we want to do that and then that. So that's 10, 11, 20, 21, 50, 50, 100. Okay, so let's see if we can see some trends here. Notice that the ToString 2 is faster in all cases. Well, not all cases. It's going to start to flip, but when we have a number that's 10, 20, 50 digits, 100 digits, at 500 it switches Okay. So at 500, it suddenly starts to become like worse. Now, in all cases, and this is the thing with development, is that you have to look at trade-offs at times, or also maybe the implementation isn't as good. But in all cases, the allocation is always less with my ToString approach than the ToString 2 approach. And remember, this is not getting the number as a formatted string and then chopping off the pieces on the left and the right. This is using big integers. Okay. So in all cases, you're allocating slightly more memory to do the ToString 2 approach. Now we're talking bytes. We're not talking gigabytes. We're talking very small numbers here. But it is different. This is twice as much allocation as it is here. Nothing ever gets into Gen 1 or Gen 2, by the way. It's always Gen 0. So, and you could kind of see as we're going up from 100 to 500, somewhere in here, I wonder if it's like 256, just because everything is a power 2 when it switches over. I don't know. That, I think that's where it switches off, where from a time performance, it's going to be quicker to do it the way I want to do it. And it seems like it's always better in terms of memory consumption. So now this is what you can use as a choice to go, you know, it helps you determine, well, which one do we want? We could say that maybe like we zero in on this 100, 500 case and we start going, well, let's do 100, 200, 300, 400, 500. And then figure out, well, maybe when we cross the size of the number gets to be over a certain length, then we switch to using the approach that I originally created. Okay. Now, it's funny that it thinks this is closure. You can't see it because my camera is hiding it, but in VS Code, it thinks the language is closure. So I don't know why. It just does. So, or is it just simpler to keep what I have? Because even when you're dealing with like these numbers, you know, definitely this way is faster, but it's allocating more memory. In all cases, it's allocating more memory, always. You know, it does fluctuate a little bit in terms of the number sizes, and, you know, we could narrow in on why that is and what's going on underneath the scenes, but it seems like in general, it's always going to be more memory to do a string allocation by calling ToString on the big integer and then chopping the parts off. But doing that also with smaller numbers seems to be much faster. I mean, you're talking here 5 times as fast to doing that. But here's another thing to keep in mind. If we go back to Spackle here and we go to the actual test here, or the way to do this, there is no way to get the size, the number of digits in the number, other than allocating another number here and then saying, do the log. Right? No other way to do it. Big integer itself does not have anything on it to tell you. I mean, there's a bit length. Shortest 2 complements representation of the current instance without the sign bit. Which is fine. We don't need the sign bit, but this isn't the bit length. It's like, what does that actually mean? You know, could we actually use that in some way? Maybe. byte count. Number of bytes will be output. That's not helpful. Get bit length. I'm kind of curious. Because if we could use that with the log of power of 2, maybe that gets us our digits. And then we don't have to do an allocation with the absolute value. Well, let me see here. Let me go back to .NET Lab. Okay. And let's say var BigInteger.parse. Just put in a big number like that. And let's say get bit length. Using system.numerics. So it says 61 here. Okay. So now I'm just curious. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually 19 digits long. Okay. Now if I come back here and I grab my formula, and I say console dot, is it worth being MERN stack? I don't know what MERN is. Right line. And we say big integer but log. Okay, so let's just get one of these because we know and then this, we're going to get rid of this. Now we're going to say value here. Darn it. Okay, so now we say, because bit length is excluding the sign, right? That's what it said. Self.get bit length without the sign bit. Okay. So if we say bit length here, yeah, that's not right. Or do we want log 2? Wait a minute. That's not right either. Well, we had hope. I was hoping that I could use the number of bits. Like if I say here console.write line value to string, and I think if I say B, that should be supported, right? Yeah. And then if I say length here, what's that? That's 62. So that doesn't actually equate because the bit length is telling me 61, but if I format it as this, it's got that leading 0. That's why. Because I think this is, if I change this to a minus, then I think that's where you start getting the 1 in front, because that's the actual This should be ToString length. Yeah, there we go. And it's still 62 because the length actually puts the bit in front, right? That tells you the sign. But if you know you need yeah, that kind of sucks. Oh well, there was an attempt. There was an attempt to try to say, instead of allocating another big integer, could we somehow use the bit length to determine how many digits we need? But that doesn't work. The log of that in base 2 doesn't quite give us the answer we're looking for. So, oh well. It is something to still consider, though, is there a switch off point here? Honestly, I think if we could get the length of the number oh, I'm sorry, I'm doing this wrong. No, wait a minute. This is the actual number itself that we're putting in here. Yeah, that's not the same thing. That is the number of digits in binary. Now, how could you say, what's the math? People, what's the math to say, wait a minute, hold on. Dang it, we don't have that. Don't we have something here in... Yeah, so notice what I'm doing here. That this is because I'm trying to get bytes and bits to do a random generation for a big integer. And so I wanted to say, if I have 10 to the number of digits, p, what would that be for 2 to the number of digits? And so I'm trying to solve for n there. That's the number of bits. What I want to do is say, I have 2 to the get bit length, and I want to get I want to do the reverse of this. I want to say I know what n is. That's the number of bits. What I want to get is p to the alpha wolfram. Alpha wolfram. Sorry for the blinding. Wait. I went to this a couple days ago, right? Yeah. Okay. Solve for P. for 2 to the n grid. I'm sorry that this is a little small to see here, but log is the natural logarithm. So if we have the number of bits there, we could take log 2 to the number of bits and divide that by, and we could make that a constant because we could figure out what log to the 2, log of 2 and log of 5 is. And there is a log there. So that may help us get the number of digits. So if I go here, we know this is 19. Okay, so let's do this a little differently. We know the bit length is going to be 61. So if we come, let's close that out, put this here. We want to do var x is equal to, and this can all be done with integers. We don't need, because I think bit length is a long. We'll find long. Okay. So we want to do long log. Math.log. That's the natural logarithm of, and we want to say here 2 math.pow, right? Yeah. 2 to the number of bit length. Okay, so that gets us the thing in the top divided by math.log of 2 plus math.log 5. What is that? It's close. $19. The adventure continues. What is this? Because we can eliminate a calculation and make this a constant. What's the denominator? Because that's a double and double. So we could say here, const double denominator is equal to that. And so then here we could just put in the denominator and eliminate, so we don't have to do that calculation all the time. We're going to have to do the other ones. But this might save us. This just might save us. What I would want to do is go through like a whole bunch of like 1 to 100,000 and say, does this hold for all those size numbers? Just to get, is this actually going to work? Because if it does, then that eliminates that allocation of the absolute value, and we don't need it anymore. That's not true, right? Because if we come back here, What happens if we say console write line? Let's take a negative number. Value times big integer minus 1. Okay. And let's just divide it. By like 10,000. What do we get? So yeah, it truncates it off. Okay. But we are doing we're doing two strings on these calculations. But those are the smaller, like that's saying only those first 5 numbers. What we could do then is also then say, well, since we're getting the minus anyway, the only thing though is if we say divrem. So if we say big integer div rem here, and we get the remainder. So we're saying take this number, divide it by that, remainder. What is that? So you see that also gives us a negative, and we wouldn't want that. But what we could do in that case is like say that's the last 3 numbers. We could just, again, on that side, we could just look to see if it's if it has a negative number, and then if it has a minus sign, and just throw it off. That's probably a third way to do this, is to use the bit length, use this technique to get the numbers. And then on the 2 strings, like we still do the calculation as normal. If I want to get 3 digits, that'll give me 3 digits. It's just that it has the sign on it, which is fine. That makes sense because it is a negative number coming in. But then we just take that piece, hey Electron, we take that piece on the front, and we just look and say, like we expected, on the left side we don't care, because if that comes in negative or not, we would just take that, and then we wouldn't have to do the logic to put the minus sign in front of the formatted string. It's only on the denominator is that we'd have to look and say if it's that, then we just go substring 1 to the end. It's kind of like pulling out the leading 0. Okay, I'm going to stop here because I've been going for a little bit of time here, and I want to digest this. But I think the next time I do a coding stream, which will probably be tomorrow morning because I have off tomorrow. It's Martin Luther King Jr. Day, and where I work, we have that day off. So I'm probably going to do another coding stream tomorrow morning, but I'm going to explore this. I'm going to explore the space, the studio space, as it were. The Saturday Night Live reference with the cowbell, which is an awesome one. And do that and see what we can get out of this. So this has actually been productive. It's been a lot of just futzing around and trying things, but I'm glad I stumbled across this because this might get us to remove a lot of allocations, and then we can tweak that to make that the final implementation of this. So with that, I am going to stop the stream here. I want to thank everybody who stopped by, either now, live, or in the future with the VOD. If you haven't subscribed to the channel, please do so. I'd really appreciate it. If you've already subscribed, I appreciate you for doing it. Again, the next time I do a random code stream will probably, not guarantee, but probably tomorrow morning around 9 a.m.-ish Central Time. If I don't do one tomorrow, another one will probably be this week, upcoming week. And then I'm going to be doing a gaming stream, Control. That game, I'm going to be doing that tonight, 6:30 or 7. And then probably doing another one, at least another gaming stream tomorrow as well. So, no wait. If you got a question, make it quick because I am going to go. But I am going to stop the stream here. So, Can I take some minutes of you? I mean, if you're going to ask me how to help you code, I can't do that. I wouldn't do that either. It's just, that's not a question I can help with. So, there is a Discord stream. Let me just check something real quick. Let me get that. Hold on. Let me get that. Server here. And that generate new link. If you really, really want to ask a question there, but yeah, how do I become a software engineer? Learn, study. There's no other way around it. I get this question a lot. There's no way to do it other than just learn, study. I should actually just put that in. If people want to ask about like how do you become a developer, how do I get better coding? You just have to learn, study, look stuff up. There's no quick, easy, dirty way to doing that other than just doing it. There's any practice, any profession, coding, medicine, construction, anything like that, you have to spend time to learn. It's as simple as that. So with that, I'm going to end the stream. I want to thank everybody for watching. Take care, and I hope to see you in the future.